formulas. Let's focus on the three double angle formulas. So the sine of 2 times an angle is this. The cosine of 2 times an angle can be used, any one of these three. And the tangent of 2 times an angle can be used by that formula. So I should be able to cross this off and set it up. Okay, we are good. So the kinds of questions you're going to be asked on the double angle formula first are going to be, you're going to be told a piece of information and you're going to be asked to find sines, cosines, and tangents of a double angle. So let's give you an example, something like question 1. Suppose I tell you that the sine of theta is 1/3, and I tell you that theta is in the second quadrant. That's important, right? Second quadrant. And you're being asked to find the exact value of the sine, the cosine, and the tangent of that double angle. Well, you begin by creating a right angled triangle that uses this piece of information. I know that the opposite over the hypotenuse is the sine, and I build my triangles pretty much the same shape every time. And in this case, I put an opposite here, an adjacent here, and thirdly, a hypotenuse here. And in this case, you're told that the opposite is 1 and the hypotenuse is 3. So far, so good. Now, you always finish by finding the third missing side. There's always going to be one of the 3 missing. And isn't that done by Pythagoras? And hopefully you can do it in your head. If not, you can do the working. But you're comfortable it's the square root of 8. So far, so good. Now, I'm going to leave it right now as the square root of 8. I know I could have called it 2 root 2, but I'll deal with that later. Let's just call it the square root of 8 just to make life a little bit simpler. Now, you are going to be asked now to find the sine of 2 theta, the cosine of 2 theta, and lastly, the tan of 2 theta. And this basically means use that formula for the sine of the double angle, the one underneath, one of them for the cosine guy, and this one here for the tan. Now, the sine of 2 theta. Well, it's going to be 2 times the sine of theta times the cosine of theta. 2 times 1/3. If I go here and I find the cosine of theta, it's the square root of 8, that's the adjacent, over the hypotenuse. But is it plus or is it negative? Because that's important for the answer. Will the cosine be a positive or negative fraction?
Negative.
And we know that because of this piece of information, right? And so it's going to be negative root 8 over 3. And that ends up being negative 2 root 8. I wish I'd planned ahead there. Negative 2 root 8 and 9. Now I'll call that 2 root 2. And there we go. There is the sine of 2 theta. Now, I want to also find the tangent of 2 theta. And so that's going to be 2 tan theta over 1 take away tan square theta. Well, again, from this right angle triangle, I can find out what the tangent of theta is. It's the opposite over the adjacent. So far, so good. Opposite over adjacent. So here it becomes 2 times 1 over root 8, 1 times 1 over the square root of 8 squared. That's 2 take away that fraction, 1 take away 1/8, And that's us now at this really ugly place. 2 take away 1 over the square root of 8 all over 7/8. Question?
Why are you taking away 1 over square root of 8? Aren't you supposed to be multiplying?
Plus. Yeah, let me start again. Well cut. So it's going to be 2, take away this guy. So it's 2 over root 8. And it's going to be 1 plus an 8. I'm too busy thinking, as always, at the wrong line. I got this guy. It's a different guy than I had originally, but it's just as ugly. We are trying.
The tangent be negative?
For 2, it was negative. Oh, sugar. Oh, and then I changed it to positive because I got confused. Yeah, I changed it all. I'm too busy trying to get to this line. I shouldn't even think about this line until we reach there. And that's, how do you deal with that ugly guy? That's what my brain was trying to get to, far too quick for its
You
own
just
good.
multiply by the reciprocal.
Okay, that's a good start. So I've got 16 over 7 root 8. That's much nicer. Do we like square roots on the bottom?
No.
No. So won't we do that little special version of one thing? And what does that get me? 16 root 8 over 7 times 8, which is 56. That root 8 can also become 2 root 2 over 56. That's 32 root 2 over 56. Anything we can do to make it just a little bit prettier to finish?
Just root 2 over 2.
Uh-oh. Are we sure it's going to be as almost
Just
Oh,
cancel it? Yeah, but I mean, it would have been nice. Sometimes it is. Wouldn't you just cancel? What's the best you can do? I think you can do 4, can't you? Can you do 8? You can do 8. I think you can do 8. If you do 8 into that, you get 4, and 8 into that. There you go.
Yeah, 7.
So you get 4 7s, but you're on the right track, right? You cancel it so you can do what you can do. And I almost forgot, because these questions take forever in a day, that we've one last guy to find, which is the exact value for the cosine of 2 theta. And I have got this guy, I have got this guy, and I've got this guy, right? And any one of them will work. I already know that the sine of theta was a third, right? That's way back at the beginning. And only because of that, I am going to do 1 take away 2 sine squared theta. Would you agree that's just going to be less work? It's the only reason I'm picking it. So it's going to be 1 take away 1/3 squared, 1 take away a 9th, and there's the answer, 1/9.
Where did the 2 go?
Yeah,
That
it's
was
2
the big-
sine theta.
Oh, 2, 2. You all caught that deliberate mistake. 7, I'm wrong that line. 7/9. I should check the signs here, just to be on the safe side. No. What is a tangent in the second quadrant?
Negative.
Negative. So shouldn't that final answer I got a while back also have a negative?
Yeah.
Isn't this one already accounted for? So we don't need to worry about it. Yeah. So let's try one more of these, but with less things going wrong. Suppose I tell you that the secant of x is 6, and the x is in the 4th quadrant. Only this time, I'm only going to ask for one of the 3, because they all kind of, once you know how to do one, you can do them all. let's find the sine of 2x. Well, I'll start off with my secant of x being being a sixth. I don't like secants or cosecants or cotangents. I'm going to return it into one of the three major ones, right? Sine, cosine, or tan. Are you comfortable that if secant is 6, the cosine is 1/6? Now I can call u the adjacent over the hypotenuse, and we can start with our triangle. We have an opposite, we have an adjacent, and we have a hypotenuse. And I know that the adjacent is 1 and the hypotenuse is 6. And if I use Pythagoras, that becomes the square root of 35. And since I'm being asked to find the sine of 2x, it's going to be 2 times the sine of x times the cosine of x. In the second quadrant, or sorry, in the fourth quadrant, what is the sign, positive or negative?
Negative.
Negative. So when I do the sine of x, which is the opposite over the hypotenuse, I'm going to do a negative of the square root of 35 over 6. Are you comfortable about that fraction and its negative? Right, now I can plug it in. 2 times ugly fraction times 1/6. And that'll cancel partially with that, and you'll get 18, and it's negative. There is our answer. And couldn't you do a cosine of 2x and a tan of 2x in a similar way? Any questions before we move on? There's lots of different things in this section. Okay.
Just one
yes.
question. Is that answer, is it negative because signs are negative in the fourth quadrant, or is it negative?
Yes,
okay.
it's negative because that is negative. The cosine we know is positive. The sine we know is negative. So together we know it's going to be negative. But it's negative because of what this guy did.
Okay.
Okay, next question is going to use, I'm not even sure I would use the word simplify, but they use that word, so I will use it as well. We're going to be asked to simplify this expression by rewriting it as a trig expression, but a nicer looking trig expression. So I guess that does mean simplify. Now, if you look at this formula here, do you recognize them as the tan of 2x formula? You agree? The tan of 2x. And wouldn't x be 5? So wouldn't this be the tan of 10 degrees? It's not much of a question, but do you understand where it came from? And that's it. You don't do any more. You're finished. How about this one? 2 times the tangent of 5 theta over 1 take away the tangent squared 5 theta. Which one of these three guys does that one fit? I think it's pretty obvious. Which one does this one fit? I'm hiding these because I do one. So what we're really doing is this x and this x is really 5 theta in this case, isn't it? So if you simplify that, what is this equal to? Think of x as 5 theta. What would this be?
That'd be 10 theta.
Yeah. It's a little bit like identities, isn't it? You know, simplify something, that kind of thing. Okay, let's move on to half angle formulas, which is these three guys here. Now, before we even worry about what these formula are, we need to learn how to tell whether we're going to have a positive or a negative answer. If you look at these two especially, isn't the answer positive or negative, and you don't really know which, you have to know. It's not so bad with the tan, because the tan, you know, you'll get the right answer anyway, plus or minus. But for these, you could get one or the other. So I'm going to put in my 0, 90, 180, 270, and then back to 360. And there's my first quadrant. Here is my second quadrant. Here is my third quadrant. And finally, here is my fourth quadrant. And we're going to set up a little table where theta is the original angle. And then we're going to have where a half theta is. And this table is basically, that's going to tell us whether the answer is positive or negative. And that's the only job for this guy. So suppose that theta is in the first quadrant. Right? So that would make theta somewhere in the range 0 to 90 degrees. Would you agree? Then what range would a half theta be in?
Be 0 to 45.
Okay. And would you agree that is definitely in the first quadrant? So if you're going to find a half angle, right? Like a half angle of 40 degrees or a half angle of 82 degrees, aren't you going to have the answer will be in the first quadrant, right? And if it's a sine, won't that make it positive? But if it's a cosine, won't it also make it positive? So you know it's going to be positive in that case, right? We're going to go through each one in turn. Let's do the second quadrant then. Put a little bubble around that there. If you're in the second quadrant, aren't you somewhere in the range 90 to 180 degrees? Great. So what range is a half theta going to be in?
45 to 90.
And would you agree that is still in the first quadrant? So if the angle that you start off with is in the first or second quadrant, won't the half angle always be in the first quadrant? Great. Right. Only two more to do, and this little table's done its job. If you are in the third quadrant, then you're going to be 180 to 270. And won't a half theta then be in the range 90 to 135 degrees? Which quadrant is 90 to 135 degrees? Where does that live?
2.
2. Can I skip to the chase here and say that one's also 2? So when we use this half sine formula or the half cosine formula, and we have to decide, is it a plus or is it a minus? Don't we have to know only what quadrant the half theta is in? If we know it's in the first quadrant, isn't the answer positive? And if we know it's in the second quadrant, the sine will be positive and the cosine will be negative. And you don't care about it for the tan because that's not an issue when you're doing the tan. Okay, so that guy is going to get used in a minute. Let's jump right into it. I need to know the exact value for the cosine of 245.5 degrees. I need to find 1/2 of somebody, because I'm going to use the half angle to get this. So if this is the original, what do you need to write in here? I'll get my calculator. What angle, if you find half of it, gives you 247.5?
It would just be 247.5 times 2.
Agreed. And that's 495. And I'm now going to change 495 degrees into something in the range 0 to 360, right? Because that's the ones we usually deal with anyway, because I want my unit circle to be usable. And so 495 take away 360, that's now 135 degrees. So that's step 1 done. Basically, step 1 is find out what theta is, the guy you're going to have. So theta is 135 degrees. Are we cool with that? Okay. If you take 135 degrees, isn't that a first quadrant, let's say, isn't that a second quadrant angle, but won't half of it be in the first quadrant? So doesn't that tell me that this answer is going to be plus? That's the only use of that job. Now, to get a cosine, it's plus the square root of 1 add the cosine of theta over 2. So it's going to be the positive square root of 1 plus the cosine of 135 degrees all over 2. And I need to find my unit circle floating around here somewhere. There we go. And the exact value of the cosine of 135 is the x coordinate of 135. There's 135, and the x coordinate is negative root 2 upon 2, all divided by 2. Are you comfortable so far about why it's a positive square root and why that's the guy that we get inside here? Cosine of 135, theta is 135. And that guy can be tidied up very marginally. There. So we now know the exact value of 247.5 degrees. It's that very ugly square root with square roots inside it. If I've done this right, shouldn't I be able to do it in the calculator and check? Okay, make sure I'm in degrees, which I am. And I'm now going to find the cosine of 247.5, and I get that ugly decimal. That's not right. I know that's not right. What's the cosine? The cosine is negative.
Yeah, it's in quadrant 2, so it would be
Oh, it's in, right. There we go. Fixed it. Actually, it's a good way to check. You can always let your calculator figure it out for you. Right, now I'll do the calculation. It should be fine. Square root of 1/2. Take away the square root of 2. Divided by 4. Perfect. You see the decimals match. We know it worked. Go.
Why is it negative again?
The answer to this question here, where is this guy? And this guy is all sine, tan, cos. And 247 is over here, isn't it?
Yeah.
And that is why that was negative.
Okay, thank you.
fact, now I'm thinking about it, wouldn't the easy way to tell plus or minus would be just to plug it into the calculator, and if the answer is positive something, it's positive, and if it's negative something, it would be negative. But my little table also works. Oh, we need to do one of these in radians then. The cosine of 13/8 pi. That's going to be the cosine of a half times 26/8 pi. Okay, which quadrant is 13/8 in? Okay, 0, pi upon 2,
Big
pi.
quadrant 4.
Right. It's what, 1 and 5/8, which takes it into here. Since it's in the fourth quadrant, what's my answer going to be? Plus or minus?
Positive.
All right, all sine tan cos. So I know it's positive. It's a cosine, yeah. So it's going to be 1 plus the cosine of theta over 2. So it's positive. 1 plus, this fella is 26/8 pi. Probably should have done this separate, but too late now. Oh, 13 quarters. Isn't that too big to fit in a unit circle? Okay, what do I subtract away from it to get a cosine that is in the unit circle so I can get its answer? I've got 13 quarters. Too big. How many pi do you subtract to get it in the right range? Try to. 5 quarters, there we go.
Hang on, I'm confused real quick. What happened
Yes.
to dividing by 2?
It's just waiting to join the question. There we go. Right,
Okay.
5 quarters. I got this guy. 5 quarters. You are down here. The x coordinate is √2 upon 2 again, all over 2. I'm getting deja vu here. Isn't that the same answer as the one before? Oh, just the sign was different. Okay, so it was slightly different. We go with that? Half angle.
In
Yes.
step 3, is that,
Here,
yeah. How'd you get from 26?
I just divided top and bottom by 2.
Oh,
Or where did
technically-
26 come from? Came from
yeah,
here.
I see the 26/8 pi.
Right. And was
Divided
your
by
question
2.
dividing, you get
Is it
13
technically not?
over 4.
Yeah, is it technically not over that too?
No, the 2 is a separate, the whole square root. So it's this guy all over 2. That's maybe not what you're asking. Let's see what you're asking. Are you asking why did this become that?
Yeah.
Is that what, right, well, that's simply just taking this fraction and simplifying it by dividing top and bottom by 2.
Okay, I see now.
That's all I'm doing. That 2 there is something else that happens really quite late on in the process. Should do a signed version of these. I think they're taking more time than I was expecting, but that's fine. And where should we go? This version of question 8. And we're going to do the sine of 11/12 pi. And if I do my all sine tan cos guy, it's in the second quadrant, so that makes it positive. And I know that I'm looking for 2 lots of this guy, so it's 22 over 12 pi. It's basically a half of, well, a half of this gets you that. So if you double this, you get that. And so it's positive. It's going to be the square root of 1 take away the cosine of 22/12 pi all over 2. The reason it's positive is because this guy is in the second quadrant, and the sign of something in the second quadrant is positive. I'll turn this guy into 11/6, dividing top and bottom by 2. And then if I go hunting for 11/6, it's here, and the cosine of 11/6 is √3 upon 2. And then just sharing out the 2's. And that would be the answer. Okay, so you're going to have an angle. You're going to have to double it because doubling and halving cancel each other out. What that does is it tells us who the theta is going to be that fits in here. You can look at the original question to decide is it a plus or a minus answer, which is what that's doing. And then you can work your way through the rest of this process.
Would you technically want to combine them?
You can't, yeah, you could. If you wanted to combine them, you would end up with an answer that would look something like this.
Square root 3 minus, you're sorry, 2 minus square root 3 over 4.
Yeah, this is correct. Actually, I wouldn't be surprised if that was correct. You know, you can try it out in WebAssign. If it takes that one, your life's a lot easier. That one would be the most natural one. And this one would be a little bit different, actually. Now I'm thinking about it, you can just keep going with these things. Can you also get that?
What does that say? It's cut off on the bottom for me.
Yeah. You could take the top square root and the bottom square root, and that becomes 2. So you could actually get there. There are 4 answers that are all the same answer, but written in totally different looking ways, right? This, and this are all the same. So I guess you'll find out when you try this one and WebAssign says nope, and then you try this one and it says yes, so you know to go that far. God, there could be other ways to write that. I mean, you could really go crazy. Now that I'm thinking about it, I could also go this way, couldn't I? Wouldn't that just be another way of writing the same answer? I don't think there's any consistent, simplified style point ways because they all look pretty ugly, don't they, no matter what you do to them? Even that's ugly compared to these.
So just trying to wrap my head around it. You double it, the original one.
You double and half it.
Then you half it.
Yeah.
In another step.
Well, you double it to get here, and then it goes in here, right? And then that answer just basically pops out again here, and then off you go. So yeah, you kind of double it to get this guy. And the reason why this works is because if you double something, aren't you probably going to make 2 a common factor, so you'll be able to cancel it down.
Okay.
But you could get questions where you could divide top and bottom by 6, couldn't you? Or even 4. Just happens to be 2 seems to be pretty common. And the goal here is to find an exact value for something that is not in the unit circles, right? There isn't an 11/12 pi here, but I can still get an exact value for it by using this kind of half angle trick formula. Any more questions before we continue? Okay, probably a lot to think about. There's just one more of these to do, and that's the half angle formulas gone, and then we have to do sums and difference formulas. But let's get this guy out of the way. you only really get one of these, unfortunately, so you have to kind of do what you can do here. I know that the cosine of x is this, and I know that x is in this range. And we are going to find the exact value for the sine of a half x. Well, the sine of a half x is plus or minus the square root of 1 take away the cosine of x, all divided by 2. Right, I'm using that formula, but I'm having x's instead of thetas. Ah, we have that plus minus fella. Remember that little box I made earlier? He does become indispensable, so I'm going to find them for you now. This little box here. If x is in this quadrant, what quadrant is this?
3.
Right. If x is in 3, where is a half x going to be?
2. So wouldn't that mean sine of 1/2 x is always positive?
Correct. And that's how you find out. Because you don't have any numbers to help you here, do you? Right? You don't have any clear value for what that could be. Are you comfortable how my little guy over here can actually help you with this one specific question?
Yeah. So don't we technically know that sine of 1/2 x is always positive no matter what?
You actually do, because
always
it doesn't
positive.
matter what angle. When you half it, it's still in 1 and 2, and 1 and 2 always makes it positive. So yes. Cosines are a bit different, right?
Yeah.
If you're in the first and second, the cosine of half an angle will be positive, but if you're in the third and fourth, the cosine of the half angle will be negative. And for the tangent, nobody cares, right? Because the formula figures it out for you. Now, that would be nice if that's all they wanted, but you know they're going to do more. We're going to take this guy now and use him here. Are you comfortable about, I now know what the cosine is because they told me. And so 1 take away the cosine becomes 1 take away this guy becomes this fella. That's 25 thirds divided by 2, which I believe is the square root of 25 sixths, which ends up being 5 over root 6. And then if you rationalize the denominator, there's your answer. Are you comfortable with that one? I went through the last bit pretty fast, but the sine x is this formula, right? 1 take away the value of the cosine, which we know, which is plus. Add them together is 25 thirds over 6. If you do that and that, you get 6.
Wait, isn't that 13ths?
Say again?
Isn't it supposed to be 13ths?
13ths. 26. 5 over 26. 26. 26. Yes. Fix the 13ths.
Wait, so I'm just confused on how we
Mhm.
get from 1 plus 12 over 13 divided by 2 to the next.
From here to here? Right, let me write that down. So what we have is we have the sine of a half x is the square root of 1 plus 12 13ths over 2. And what I'm doing is I'm going to add these two together by calling this 13 thirds. That's 1 plus 12 thirds. And that's now going to become this guy plus this guy is 25 thirds. And why did I say thirds? I keep doing that. 13ths. 25 13ths over 2. 25 over 26. So are you happy from there to there that then give you that?
Why is it 25 over
Yeah.
26? Wouldn't it be 50 over 13?
That's what I was thinking.
Oh, multiply by reciprocal is multiply by 2. Ah, you caught me. 5 root 2 over 13. I've been telling everybody today my brain is somewhere else because today is Valentine's Day and I haven't got my wife anything and I've been mulling over it in my head, and so I'm half here and half somewhere else. Not a good excuse, but it's the only one I have right now. So there. So what would that get me? That would get me 5 root 2 over square root of 13. 5 square root is 26 over 13. I guess that would be the best you could do. If you go through these slowly and watch out for arithmetic mistakes, which I'm very prevalent on today, you should be able to get through them okay. Right. So we've done double angles, not many of them, a few half angles. All we've got left is called the sum and difference formulas. This is basically formulas that allow us to combine a sum of two trig functions together, or a difference for that matter, or rewrite a product as a sum. They all basically involve you just using given formulas. So I'm not going to write them all down because that would take me forever in a day. So I'm going to see if I can just find them and I'll show you the page number and you can go and look at that page number later. Okay, so we are on 7.3. Check. And let me find it. There we go. Okay, I'm now going to nip over to show you where those, and there's a multitude of these formulas. The product sum formulas, and we're doing the sums first. So if you want to find the sine of u plus v, you can do it with this guy. If you want to find the sine of u minus v, you can do it with this one. No, wait, this here is just coming up with the formula there. There we go. Here are the four combinations of sines and cosines, and next to them are the formulas that you can use to convert them. So I got these guys. And there's the other four. So the first four are product to sums. What you're meant to do is just write them down somewhere, and when you need to, you go and you look at them. And so that's the product to sum formula, and they are, do they have a page number on this? It's just above example 9 when you try to find it. And then scroll a little bit lower, and then you get the other way around, which are the sum to product formulas. So let's leave those guys and I'll write them down as we need them. So it's just some more stuff you're going to have to print out or write and put in little cards. You know, like you've probably got a card with the double angle formula, another card with a half angle formula, have a third one with the product to sum formula, and a fourth one with the opposite sum to product formula. Let's return to our last few questions, which with a bit of luck we'll get done. Because there are, I believe, only 4 of them. Oh, I'm wrong. 5. So the questions are numbers 10, 11, 12, 13, and 14. And all these questions are going to use these particular guys. So in no particular order, here is question 14. We are being asked to write the sum as a product.
Oh, can you show your screen?
Oh, I thought I had. Gotcha. There we go. So these questions use these formula, right? So question 14 says, write the sum as a product. And we're being asked to take the cosine of 9x and add it to the cosine of 4x. And I'm going to go hunting for a cosine plus cosine. And the formula that they have is written in this format. Cosine x plus cosine y is equal to 2 times the cosine of x add y over 2 times the cosine of x take away y over 2. I wish they hadn't used x's and y's. I'm going to change that to a's and b's. So the cosine of a plus the cosine of b is twice the cosine of adding them over 2 multiplied by the cosine of subtracting them over 2. The reason why I think this is going to be easier is that guy there, the whole package is A, and this guy here, the whole package is B. Isn't it a little bit distracting when you have an X and another different kind of X? So I'm calling them totally different letters to make it a little bit easier to identify them. And in this case then, it's going to be the cosine of 9x plus the cosine of 4x. And it's going to be 2 times the cosine of a plus b, that's 9x add 4x over 2, times the cosine of a minus b, which is 9x take away 4x over 2. And that becomes 13x over 2. And that becomes 5x over 2. And that's it. You're finished. So identify the correct formula, figure out who A and B are going to be, plug them in, tidy up. Okay, that was 14, randomly jumping around. Let's try 12. Okay. In question 12, you're being asked, see what you're being asked for. We should have that formula somewhere. Here we go. This time, you're being asked to write a product as a sum. So in this case, you're being given, what are you being given? The cosine of 5x times the cosine of 3x. So I go hunting for the formula that takes products into sums and found it. And the combination I want is this guy and this guy. And the formula I'm going to use then is called, what's that, cosine, cosine? So it's going to be the cosine of u times the cosine of v. And it's a half the cosine of u plus v. So just cosine of u plus v. Take away the sine of u plus v. So it's 1/2. This guy is going to be u, this guy's going to be called v. So what have we got? u plus v is 5x plus 3x, that's all. Take away the sine of 5x. One of these should be minus, and yeah, this one. Yeah. 5x, take away 3x. And that's a half. The cosine of 8x, take away the sine of 2x. And you've written a product as a sum. Here, you've written the sum as a product. That's the two directions. Find the right formula. Figure out who A, B, or UV, whatever lettering they happen to be using. And we are good. Got one more. Yeah, we can do one more. Do 11. Question 11 says, write the product as a sum. Well, and the one that we're meant to do is the sine of 2x times the sine of 6x. And this guy has a little hiccup at the end, which I'll have to show you. So product to sum, sine times sine. And the formula for a sine of u times the sine of v is 1/2 the sine of u take away v. No, scroll the wrong one. 1/2 the cosine of u take away v minus the cosine of u plus v. So sine 2x times the sine of 6x. It's 1/2 cosine of 2x take away 6x minus the cosine of 2x add 6x. And this is where the weird thing happens. One of those terms has a negative x's inside it. And we don't want negative x's inside it. We have to figure out how to rewrite this, the cosine of negative 4x, how to rewrite it without having negative 4x inside it. That's what the problem is. Put that guy over here. This is going to be our last question. So there are two ways to tackle this question. Let me show you the easiest way. If you don't like the way something has been written, and in this case it is possible to do it, couldn't I just rearrange it to be the sine of 6x times the sine of 2x? Couldn't I just swap the u and v's? Would that make sense? Now, what would that do to my calculation? Well, it would be 1/2 the cosine of 6x take away 2x, subtract the cosine of 6x add 2x. And that gets me the cosine of 4x take away the cosine of 6x, and we solved the problem. That would be the easiest way to solve this, right? Just to switch the order so you don't have to deal with the cosine of negative 4x. The second way is to just know the following. Because the only two guys it's going to happen to are sines and cosines. So I'm just telling you that the cosine of a negative angle is the same number as the cosine of the positive version. And when you do it with a sine, you get the negative of the positive version. So in this case here, if I use that property that I've now just told you, this guy becomes positive cosine of 4x, take away the cosine of 8x, and we get the same answer as we did up there. Now, if you're trying to figure out how is this one true, here's a proof for you. If you take an angle in the first quadrant, let's just call it A. If you find the angle with minus A, doesn't it look like that guy? Okay, for any angle A, isn't negative A just going to be the same amount, but in this quadrant, right? What's the cosine in the first quadrant? What's the cosine here? So technically, isn't the cosine of negative anybody the same thing as the cosine of that positive same guy? And all I've done is use minus 4x as if it was A. Okay. Does that help you not think of it as magic, right? There is a reason why it's true. Are we good? Well, I wish we could say that we are finished this very, very esoteric bit of trig, right? We're not finding the lengths of anything or measuring anything that you would typically see, but it is some of the kind of things you can do with trig, the algebra of trig, and that's what we're trying to be doing.